Alright, so I took some questions out of the book here that were a little bit more difficult for people who were having the problems with the fraction linear equations. So just a hint, some people learned cross multiplying a long time ago. So if you want a hint, if you want to learn how to use cross multiplying using equations like this, it could be a little bit simpler for you. For example, if I have something like a over b is equal to c over d. So these are two fractions, okay? What you were taught, or what you should have been taught, is that if you ever have a fraction equal to a fraction, you can actually multiply the b up and across here, and you can multiply the d up and across here. So some people use that as a quick way to do cross multiplication. So if we were to rewrite this, we'd have AD is equal to BC, okay? And I'm going to use the first question right away so that you can see the example of this. So if you look at question 2a, so this is exercise 6b on page 99 in the book, all right? And if you can see now, we have a fraction is equal to a fraction, and what is worse is our x is in the denominator. So one of the key hints I gave you in the previous videos is that we want to get rid of the denominator. So if you have a fraction equals a fraction, it gets quite easy because you can multiply x up and across here, and you can multiply 7 up and across here, okay? And what you have is 7 times 3 is equal to, well, 2 times x. And so if we make this a little bit cleaner, we have 21 is equal to 2x, and we divide by 2 on both sides, and I have x is equal to 21 over 2, and you can leave it as a fraction like this. So there's an example of this cross multiplying here. So if you want to use cross multiplying, go ahead as long as you use it right? And so we can use it on all sorts of equations that are a fraction equal to a fraction. So for example, if you look at this one here, my second one, you should be able to see, well, this is actually a fraction, right? And 4 can be written as 4 over 1. So if you'd like, we can rewrite this as 4 over 1. So now we have a fraction is equal to a fraction, and we can use this idea of cross multiplying. So what it says is the 1 should go up and across here, and of course 1 times anything is, well, just 1, or pardon me, anything, right? So 1 times 5x plus 2 is 5x plus 2, and then I multiply up and across here the x minus 1. So I take the whole thing and multiply it up here. So I have 4 times x minus 1, all right? So now we have our second stage of our equation, which is expand every time we can have a chance. So I expand. So I'm going to bring my equal sign down here, keep them in line. I have this, 4 times x is 4x, 4 times negative 1, negative 4. And from now on, the rest of the equation to solve is pretty straightforward. So x is algebraic terms on one side and numbers on the other. So I would take this 2, I would put them over there. So if you do that, you have to minus 2 on this side, minus 2 on this side. So these cancel. And I would take my my 4x and I would put it over here on this side. To do that, we do subtract 4x. So these go away. But then I have to subtract 4x on this side here. So negative 4x plus 5x is x, 1x. And then we have negative 4 subtract 2 is negative 6. So there we have that one there. So getting rid of the fractions when we're using cross multiplying is quite easy and efficient. So I'll do a few more just so you can see. So once again, we have a fraction is equal to a fraction. So what I'm going to do is I'm going to group this x plus 3 together, and I'm going to cross multiply him up across, like so. And I'm going to cross multiply him x times 5 across there, so I have 5x like that. Next step, FOIL. So we have 2x plus 6 is equal to 5x. I'm going to put the x's on one side, so I'll take him and I'm going to put him over here. So I subtract 2x on this side, subtract 2x on this side, and if I rewrite it, I will have 6 is equal to 5x subtract 2x is 3x. And then our final final rule is that we want to have x on its own, so we divide out the coefficient. So I divide out 3, but I have to do it on this side. So we have x is equal to 2. So once again, cross multiplying, all these 3 examples are great examples of cross multiplying. So remember, fraction equals a fraction. You're allowed to cross multiply to get rid of any denominator. But if we look at the next one, if we look at this one, I have a fraction, subtract a fraction is equal to 3. So this is a little bit different and causes a little bit more problems for us. So because of that, we can't do any cross multiplication. So the easiest way to do this is try to find the common denominator for 2, 4, and technically 3 over 1, right? Because that's our fraction. So if I asked you to find the common denominator between 2, 4, and 1, most of you should say that it's 8. It's the lowest common multiple between 2, 4, and 1. Okay? So now that we've found this lowest common multiple for this linear equation with fractions, the easiest way to figure out how to get rid of the fractions is I would like to have this denominator as an 8, so I would times it by 4 here, but I have to times it by 4 up here. This denominator is 4, but I would like him to be 8, so I times it by 2 here, so I have to times it by 2 up there. And finally, this denominator is 1, so I need to times him by 8, and that way I can times this side by 8 as well. So what you essentially have is 4x minus 2x over 8 is equal to 24 over 8. Now this is the next big hint or the big trick, which is helpful. So my last videos I had a different method, but maybe this method is easier for you. Once you have the common denominator for all these here, all right, you can just throw it away. And if you're wondering why, I'll show you. Okay, so if I times this by 8, you would agree that these cancel. So if I times one side by 8, I have to times the other side by 8, and guess what? They're gone. So this is why I say that once you have the common denominator in every fraction in a linear equation, you can throw the 8 out. Now, if you like the step that I showed you, you can show that step just so that you're happy that you're doing it correctly. All right, so that is no problem. So what we have in the end is a linear equation with no fraction, which is quite easy to solve. So 4x minus 2x is 2x, and I have 24. And finally, the last step, we divide by 2 to cancel the 2, and I have x is equal to 12. All right, so that's getting more involved. So these are 3 terms with fractions, and we have to try and get rid of the fractional piece in this linear equation. All right, so if we look at our next one, once again, if you like the step before, I'm going to find the lowest common multiple to find the common denominator between the 3, 12, and the 6. So the lowest common multiple for these 3 is 12. So that should be helpful for us to get rid of the denominator here. If that's the case, what do I have to do to each one of these denominators to make them the same? Well, I have to times this denominator by 4, because then I'll get my 12. But I have to multiply up here by 4, and I have to group these in brackets. The next one, 12, well, we already have a common denominator, so I don't have to do anything to this fraction here. All right. And the last one is 6. Well, we need to change this to a 12. So if I times this by 2 here, I get a 12. But I have to multiply it by a 2 here as well. Okay. So if we have this here, we can see that we're going to have 12 as the common multiple, or the lowest common denominator, pardon me. And we have 4 times x minus 4 on the top here, from here. The subtraction sign, we saw in previous videos that when the subtraction sign comes up, we have to draw the line underneath here and apply the subtraction sign to this whole 3x plus 7. So that is usually an error that kids do. They forget to put they just put the minus in front of the 3x, but you'll know that once we FOIL, the negative will actually switch the sign of the 7. So that is usually a mistake that students do. And finally, we have on this side, well, 12, because we have the 6 times 2, and we have 2 times x plus 1. All right, so I put both of these on my common denominator. I have the same common denominator here, and as you saw in the previous question, I can now throw away my 12 and 12 on each side. So I have 4 times x minus 4 minus 3x plus 7 is equal to 2 times x plus 1. So we've gotten rid of the fractional piece of this equation, which is great, because then this side here at this point is expanding, adding like terms, and putting all the algebraic terms on one side and anything without an algebraic term on the other side. So if we do this, I have 4x and negative 4. This negative is there's our hidden 1. So negative 1, and 2 and 2. Just draw this. This is a 1 here. So if I expand this, I should have 4x minus 16, negative 3x minus 7 is equal to 2x plus 1. And at this stage, I see some people moving numbers around altogether. What I would do is add like terms. For example, if I'll circle the like terms here. I have negative 3x and 4x. So 4x minus 3x is just x. So we have x from that. And then if I circle these, I have negative 16 and negative 7. So that I will have negative 23 there, equals to, well, I'm just going to rewrite my bottom here. I haven't touched this other side, so I'm going to rewrite it. Okay. Finally, any value with x's on one side, any values without an x on the other. So in this case, I will subtract x on this side. So these go away to 0, but I have to subtract x on this side. So I'm putting all my x's on this side here. So 2x minus x is x. And then I would like to take this plus 1 and I would like to put them on this side. So if I subtract 1 on this side, then of course I have to subtract 1 on this side. And negative 23 subtract 1 is negative 24. And now notice that we don't have any coefficient in front of the x. So our answer is just x is equal to negative 20, negative 24, which works out quite nice. We don't have to do any extra work. So there are some examples from the next piece of homework that will help you out with solving fractional linear equations. Okay, try to use a tip. Try to use cross multiplying when you have a fraction equals a fraction. And then when you have something else where you have 3 terms where you cannot use cross multiplication, try and find the lowest common multiple. Make sure you have the common denominator in each piece here. And then you can throw away the, of course, denominators when they're all equal on both sides. Okay, so try that out. Leave a comment if you still don't understand, or if there's another problem you would like me to do, or make me another video.